Hi, today we're going to be talking about the ocean floor and margins. We can all imagine a walk across North America, crossing the Mississippi, traversing the Great Plains, scaling the Rockies. But what would it be like to walk from New York Harbor to the coast of Great Britain? Would the land above the water resemble the land beneath it? What does the ocean floor look like? You might be surprised. Below the surface of the ocean's great blue expanse is a terrain more varied and dramatic than any landmass on Earth. Mountains taller than Everest, chasms deeper than the Grand Canyon, and plains more expansive than the Siberian steppes. Continental margins are not all alike, but they are not all different either. There are two basic types. Each one has different characteristics, which are a function of the processes involved in the formation of the two types of margins. The classic margin is based on the U.S. East Coast example. This margin is an example of what we call a passive margin, because earthquakes and volcanoes are essentially absent here. As the plate on which this continent rides moves against the mid-Atlantic ridge. Another type of margin is modeled after the U.S. West Coast. This margin is sometimes characterized as an active margin because it's on the leading edge of the North American plate. Margins along plate boundaries are mountainous with narrow shelves right here, steep slopes, and rugged topography. Passive margins have wide shelves, really big. They have a more gentle slope. There are no trenches among a passive margin. There's no trench here. Active margins do have trenches. Continental margins have the same characteristics as the adjacent portion of the continents. Thus, the continental margin off of California is rugged and steep, as is California. The margin off of Texas and the states along the East Coast is wide and flat. The Texas coast and East Coast have flat coastal plains bordering the ocean. You can easily predict the type of continental margin if you know the topography of the adjacent landmass. So let's take a walk. Topography of the North Atlantic Ocean. The continental crust extends into the ocean for several miles. Right here, where it becomes a continental margin. The rest of the ocean is called the ocean basin. The deep floor extends for thousands of miles with an average depth of 3,795 meters below sea level, compared to an average height of 840 meters above sea level for land masses. Our journey begins with a shallow descent from the mid-Atlantic beach to the continental shelf, a narrow ribbon of seafloor that extends around the world's continents and ranges between 30 and 1,300 kilometers wide. At the edge, it's only about 200 meters deep. A uniform layer of mud and other sediments that originated on land covers most of the continental shelf. Most fish are caught in its teeming waters, which are also home to the bulk of the ocean's vegetation and animal life. The edge of the shelf is the sea that we are most familiar with, where we swim, fish, and go boating. It's relatively warm and shallow. Next, we reach the continental slope, where the seafloor begins its descent into the depths. Typically, slopes have an incline of 4 degrees, although they can be as steep as 25 degrees. Cutting through parts of the slope are immense V-shaped canyons that wind outward to the deep sea and often connect with mouths of rivers. When sediment that has accumulated on the shelf becomes unstable or is shaken by earthquakes, it can avalanche down these canyons. This can trigger tsunamis, powerful waves that can travel for thousands of kilometers across the sea of the ocean. The continental rise at the base of the continental slope there is where sediments have descended from the continental shelf and accumulated. The width of the rise can vary from 100 to 1,000 kilometers, and it has a very gradual slope. Now that we've hit the deep ocean basin, we can set out on the long trek across the ocean floor. All the way down at depths below about 4,000 meters, the seafloor is called an abyssal plain. It essentially is flat because the rugged topography of the underlying basaltic crust is draped in sediment that can be up to 5 kilometers thick. The abyssal plains cover 25% of the Earth's surface. Great expanses appear barren, but in fact animals that live on the sea floor, called benthos, are abundant and diverse. Most are invertebrates, such as sea anemones, sponges, corals, sea stars, sea urchins, worms, bivalves, and crabs that have adapted to the cold water and high pressure with slower metabolisms. Near the center of the ocean basin, we'll find ourselves climbing a mid-ocean ridge, a line of volcanoes about 2,500 meters high and about 70,000 kilometers long. It stretches across the ocean floor and around the Earth like seams on a baseball. They are also called spreading centers. These mid-ocean ridges are where new oceanic crust is created. Luckily, we are not in the Pacific Ocean, where we would have to hurdle an ocean trench or two, 3 to 6 kilometers deeper than the adjacent ocean floor. These are the deepest places on Earth's surface. The most famous one is the Mariana Trench in the western Pacific. It's 11,022 meters deep, way deeper than Mount Everest is high, and about 2,550 kilometers long and 70 kilometers wide. Near the center of the ocean basin, we find ourselves climbing a mid-ocean ridge. A line of volcanoes break. Seamounts and guyots are volcanoes that have built up from the ocean floor, sometimes to sea level or above. Guyots are seamounts that have built above sea level. Erosion by the waves destroyed the top of the seamount, resulting in a flattened shape. Due to the movement of the floor away from oceanic ridges, the seafloor gradually sinks and the flattened guyots are submerged to be undersea, flat-topped peaks. We know that the tops of guyots were once at the surface because they contain evidence of fossils, such as coral reefs, that only live in shallow water. Seamounts, conversely, represent volcanoes that did not reach sea level, so their tops remain intact and they're shaped like a volcano on land. Atolls develop break. Break to here. Seamounts and guyots are volcanoes that have built up from the ocean floor, sometimes to sea level or above. Guyots are seamounts that have built above the sea level. Erosion by waves destroyed the top of the seamount, resulting in a flattened shape. Due to the movement of the ocean floor away from ocean ridges, the seafloor gradually sinks and the flattened guyots are submerged to become undersea, flat-top peaks. We know that the tops of guyots were once at the surface because they contain evidence of fossils, such as coral reefs that only live in shallow water. Seamounts, conversely, represent volcanoes that did not reach sea level, so their tops remain intact and they are shaped like a volcano on land. Atolls develop with underwater volcanoes called seamounts. First, the volcano erupts, piling up lava on the seafloor. As the volcano continues to erupt, the seamount's elevation grows higher and higher, eventually breaking the surface of the water. The top of the volcano becomes an oceanic island. In the next stage, tiny sea animals called corals begin to build a reef around the island. The type of corals that build the reefs are called hematypic corals, or hard corals. Hematypic corals create a hard exoskeleton of limestone. Billions of these limestone exoskeletons are the reef. This coral reef, called a fringing coral reef, surrounds the island just below the ocean's surface. The thin, shallow strip of water between the fringing reef and the island is a lagoon. Over millions of years, the volcano erodes and sinks to the sea floor. This process is called subsidence. The seamount erodes into the sea, its top layer made flat by the constant pounding of the powerful ocean waves. As it subsides, the flat top seamount is called a guyot. As the island subsides to become a guyot, its ring-shaped fringing reef turns into a barrier reef. The barrier reef is further from shore and has a deeper lagoon. The barrier reef protects a lagoon from the harsh winds and waves of the open ocean. And as the volcano retreats to the guyot, we end up with a lagoon, a very small island, and an atoll. After a 4,000-mile trek across the ocean basin, we begin to climb up the continental margin, right here, to dry off on the west coast of Ireland.